Hello, what's up? Welcome to Bromtech Engineering, and here we are going to unscrupulously break down engineering concept, teach you how you're going to design your structures, the best softwares in the market, and how you will efficiently carry out inspection and the execution of the works on site. Today we're going to start with introduction to Procon. I'm going to take you through the Procon interface after installing it, and it's maybe you're a first time user. I'm going to show you how you start interacting with it, and in the subsequent classes we will get to learn more about it, and we will even design elements with it. So welcome, join me. If you've not subscribed to this channel, kindly do so, and press the bell icon so that you can receive notifications in case we post any new content here, and we will continue learning together. So welcome, and you're highly welcome to this. If this is recommended for civil engineering student, practicing civil engineers, and all those in the construction industry. Even if you're a contractor, you need to know how to use some of these softwares, how to carry out checks, how to design a few elements in there so that you're able to do the works even on your own. So thank you, and join me as we're going through it. I have already installed my Procon. It's here on the middle right, and this is the Procon icon that appears on the desktop. So to open it, you just click here, but apparently I have already opened mine. It is right here. So to open it, you click here and you wait. So you wait for like 30 seconds, and then it will open up, and this is how your Procon will look like. And from observation, you can note that I'm using Procon version 5.0. So that is what I'm going to train you with. Now, the first thing you interact with when you open Procon is this interface, and it has a very nice wallpaper over here. Then we're going to start looking at what is found in file. But before we do that, if you have issues with your license or you have not been able to activate your software, you can use these two, update and license, to carry out the works, and kindly ensure you have the original version so that we also promote the developers. Yeah, also using pirated softwares is not good. The first thing we look at is file. You have all the tools you need at the top, and when you open it, actually opens the calc pad first. So you start with file, but above file there is this Procon icon. You see, you can restore something, move size, minimize, maximize, or close a file from top here. So you can either close using this or using this, or do maximization or minimization of your screen using these on the top right, or you can use the ones found at the Procon icon. And after that, you can go to file. File is the first one here. Then from file, you can open a new document. If you want to start a new project, you can always go to new, and then it will start a new project. And then you can open an old project or something you have been working on and you had saved it. It can open from here. Also, we have these other commands which are grayed out, including save, save as, close, and close all. These ones will become active once we have a project running. But because we have not yet started working, we don't have any ready project running. So we cannot save anything or we cannot close because we don't have anything running. And then you can also set up your page from here or print your work using this icon. Now, of most importance is the Procon options. Here you need to understand a few parameters, and I'm going to take you through. Once you open Procon options, you have general. Under general, you can change the wallpaper so that it appears different here. And then you can also change the backup interval, because Procon normally carries out timed backups when you're working. So you can change the interval to whichever time you so wish, and you see the maximum is 60 minutes. And then you can also say no timed backups. So you can put that which you deem fit. But for me, I like working with 2 minutes, because you see this is the minimum, so that it backs up my work frequently as I'm working. Next is the working folder. When you click on the working folder, you're able to select a folder where you're going to store your work. And as you can see, I have folders of clients here. So you can choose a working folder and save your work, so that you will be saving your work under the folder that you decide. And from working folder, you can even create a new folder by using this. From there, you move to general preferences. Under general preferences, there are a few things that you need to note. Number one is the code that you're going to use in design. And Procon can carry out design for concrete, steel, timber, wind, masonry, and RC detailing. So there are already default codes of practice. But right now, as you know, we are actually shifting from British standards to Eurocodes, or these any other codes to Eurocodes, because Eurocodes are trying to unify the whole world, such that if you have nationally agreed values, you can create your own local annex that you will be using with reference to the Eurocode. And actually, this harmonizes design all over. And we believe that once everybody adopts the Eurocode, we will be able to have harmonized designs across the world. So here you can do concrete. Uh, and you can see there are many codes. You have ACI from America, you have the British Standard, both the 1997 and 1985 versions. You have Eurocode 2, and then you have many other, including SABS that is used in South Africa, and many other codes. So here is where you get to change the code, and you can change the code for all elements as you would wish. You can also change the units. In Kenya, we were colonized. Actually, I'm recording this video from Kenya, and we were colonized by the Britons. So we use the metric system. But if you're in places like the United States of America, you could use the imperial system, because that is what is generally accepted there. The metric deals with millimeters and meters, and the imperial deals with feet, inches, and miles. So after changing your code of practice and stating the units you're going to use, there are other parameters that you can use. For instance, the FY. FY in Kenya, the readily available bars, we normally use an FI of 500. But since also standardization of these bars, or quality control is not always assured, you are advised to use 460. But if you're sure the manufacturer is giving you the right product, it has been tested, or you can take your bars and test, and they pass 500, then you can use 500 of your bars. And then you also have mild bars. Mild bars we normally use 250. The difference between the mild bars and the high yield bars, the high yield bars are ribbed, but the mild steel bars are the ones that are round, which we normally denote as R. They don't have any ribs, or they are not even twisted. So you can see how they are designated here. Actually, when we were twisting the bars, we used to call them Y, but nowadays we refer to them as T. So you also have these round ones as R, and they are normally used in the design of links that are used to tie columns, beams, or any other elements. And then you can also state the maximum bar diameter depending on the country where you're designing from. So in Kenya, the maximum bar diameter is 32, though you can get 40. You can get customized 40 if it is really necessary that you use 40. But readily available, you will get 32, and I believe that is going to work. But when I am working on simple, let's say 4-story buildings, 5-story, or even up to 10, I tend to limit my bars to 25 because these are readily available, and they are anything less than 25 can be cranked, it can be bent or cut on site easily. But when you have 32 and above, even tying the bars becomes a challenge, and sometimes you require to weld. So I normally try to limit myself to use 25 as the maximum bar. And then FCU, this is the concrete class of your beams or slabs. Then you can use 30 or 25 or even 20. For columns, you can also state the ones you want to be generally using. And then for bases and slabs, you can also use state the class you will use. Actually, it is preferred that you use the same class so that quality assurance and material testing becomes orderly, and it's better for you to check your work on site. Because once you state different classes of concrete, by class we mean the compressive strength of that concrete. Um, Checking on site might give you trouble, because sometimes you might forget to give the instruction, or you might give the instruction but it is not followed. So it is always good to use a uniform class of concrete, so that even your foreman or your fundi, here we call them fundis, the laborers, the casual laborers and the skilled ones can always use the same class. When you're also working with steel design, Procon is very good. I have tried using Procon 5.0 in designing steel, and actually it is super, let me say so. So you can state the yield strength that you want, depending on where you are, the one that is readily available from the market or the one that is designated from the manufacturer. You can also state the tensile strength of that bar, or the steel that you're using. So these two depend on where you are in a country, and that which your manufacturer can give you. You can also change a few parameters depending on the connections you have, if you're going to do steel design. And then, because we normally design for bolts and weld connections, we can also input the parameters. So here you can input the parameters of your bolts, or and down here you can do settings for your weld. And then, for instance, you see there are different grades of bolts that you can use, and their types, that is the bearing and the HFG. And you also have shear analysis and tension analysis, and how you want them to occur, either linear or nonlinear. And you can tell the software to use only the preferred sizes as you would wish. Also, in weld settings, you can set the ultimate strength of your weld connections and the shear analysis that will be run when you're doing weld settings. So from here, these general preferences are of importance because they help you set the parameters before working. That is why it is always good you set them earlier, prior to your design or analysis, so that you proceed in an orderly manner, because sometimes you can even forget after you've designed, and then you've gone to site, you realize, wow, I had not specified the yield strength of my steel when I was designing, so I have a wrong design here. So it is good you change from here. And then from Eurocode takes you back to these that we saw, these box that we saw under general, but again it opens this box. Now this table contains parameters as agreed by different countries. These are parameters from your design codes. And then you see, because we are moving to Eurocode, it has even made it easier. They have given us nationally acceptable values for Eurocode here. So you see, we have an active country, and then you can see it is only UK. Actually, if your country has a national annex, you can come up with these parameters and also feed them here and save them here for your works. So when you look at Eurocode 1, these are the nationally acceptable values for the UK, and then Eurocode 2 and 3 and 4. These are the values that you might wish to have as you're carrying out your design. So it is, if you have forgotten or you cannot access your code right there, you can come here and find out what is the value assigned to those parameters according to the UK national annex. Because in my country, because we have not come up with our own national annex as Kenya, we normally accept the United Kingdom national annex, so you can get it here. Yes, having said that, we are done with Procon options. Remember, this was under file. Now when you come to home, home does not have much, but it has things to do with the text that you're going to use and all these other stuff, and it includes updating your software or renewing your license. So quickly, I would wish to proceed to analysis. For analysis, it has two sections. The first section is for the analysis of structures. You can use Sumo, Frame, or Plane Stress, and these three allow you to model an element using nodes and line beam elements. After modeling, you can analyze, and it's going to give you your analysis results, including forces, shear, bending, and all those other results that you normally get from an analysis. You also have analysis of beams. You can analyze a simply supported single span beam or an elastic supported beam, that is a beam on elastic support. This comes in handy when you are analyzing beams on the foundation, because beams on that foundation are normally beams on elastic supports. So they come in handy if you have your axial loads from your columns. You can feed them, and then you're going to get the analysis of that. Actually, when you're under analysis, this does not design. It purely does analysis, and then you can transfer the data elsewhere for you to be able to design. From analysis, you also proceed to steel. Steel now enables us to design all these other elements highlighted here. You can design a strut. You can also design a member for combined forces. And when it comes to girders, you can design these beam girders, or you can do also plate girders. These are normally used in bridges in most cases. You can also do moment connection design for designing of column base plates, that is for steelworks, beam column connections, the apex of members like trusses, and you can do a connection of all of section if you're having some plumbing design that you want to do with steel. You can also use here. And you can also do shear connections, including end plates, fin plates, cleats, bolting. This is where you design your bolts. Remember the bolts whose parameters we set earlier. This is where you design them, and then welds and all that. You can also do anchor bolts. These are used when you want to anchor your element to concrete, so that you have the bolts now coming to tie your steel to that concrete, so that you can proceed with a steel member if you had started working with a concrete member. Like when we're designing steel columns, we normally start by having the base plates, and then the base plates could be inside concrete or on top of concrete. So you could be having anchor bolts connecting the base plate to concrete depending on what you are designing. And then the most common is concrete. This is the most commonly used because reinforced concrete structures are commonly uh, acceptable and used in construction all over the world. So here you can do design of continuous beams, and then you can also do design of pre-stressed elements. Uh, Actually, this captain is very handy when you want to do things that are pre-stressed. You can see how it appears, including cables. And then let me close this. Yes, and then you can do rectangular slabs, rectangular columns, circular columns, general columns. By general columns, we mean columns of shapes which cannot be defined as either rectangular or circular. Like if you could be having an L-shaped column or a T-shaped column, you could, or an H concrete column section, you could use this to model it and design it appropriately. You could also design retaining walls for retaining earth, water, and any other structures. You could also design pad footings for your columns, piles, and you can do some checks to your members. You can check beams for uh, cracks. You can also do punching shear check when you're designing flat slabs and you're designing columns with a lot of too much axial force on a pad footing. You can check for punching shear here. So this is mostly used, and I believe this is what you're going to use mostly. You could also design composite sections. Majorly, these two beams and continuous beams are used in bridges, actually including field columns and encased columns. For instance, if you're building in Mombasa, Mombasa is a city in Kenya. It is in the coastal county of Mombasa, and it is bordering the Indian Ocean. So when we're constructing there and we want to do a steel structure, from the foundation and even on the superstructure up to a certain level, we normally encase the steel columns in concrete so that they are not easily affected by the salts in the water. And since there is also a lot of humidity, you're trying to reduce rusting of the elements, because when steel rusts, it uh, is actually affected because it expands and then starts peeling off, and then you're going to have a lot of problems in your structure. So from composite, you could also design timber and masonry. This is a timber beam. It's designed here, and you can design a masonry section, masonry wall, and a free masonry wall. All these are in Procon 5.0. And if you do not, because majorly most people don't work with masonry or timber, or maybe we don't have a lot of information on masonry and timber, you could study the Eurocodes. They are very rich in information on how you're going to design your members. And if you design and get stuck, we're here to help you. We will be doing videos on all this. And also you could just go through your codes, because the codes have been harmonized in a way, and all information has been fed there in a way that it becomes easy for the designer to get them. And then you can also do CAD and detailing. Actually, gone are the days when we just used to use AutoCAD only for detailing. Uh, right now, we actually use many softwares for detailing, and you just have to pick your best and run with it. So in Procon 5.0, some people prefer detailing with it because once you detail, it is able to help you generate your bar bending schedules, determine the quantities of reinforcement you will need. It will also help you get the weights, and this can help you when you're trying to procure. Yes, this is work for quantity surveyors and people who do cost estimation in building. But as engineers, since we normally provide bar-bending schedules, Procon comes in handy so you don't have to go and start again doing it manually. Therefore, it can help you save time, and we will actually look at all this. We also have general information, and you could design for wind, gutters, and you also have databases under general information. Uh, these databases contain properties of your materials and sections. Remember, we are designing for steel, for example, and this still has different member sections as they come from the manufacturer. So not all manufacturers produce the same member sizes, and not all countries have harmonized sizes of members. So you should go through the catalogs of uh, steel manufacturers and get those sizes so that you feed them. When you're carrying out a project, you exactly know what you're going to get in the market. So you can actually input your sections, although Procon has some other sections in it already. You could also design geotechnical elements, including slopes and rocks and piles. Remember, we also looked at piles in concrete. You could also design piles using this software. And then, of course, you have scripts of all these elements mentioned here, including angles and anchors and all that. And you can actually add, edit, or remove any script from here. And if you need any support, you could get it from here. You can request or message the support center and they can help you. And then, of course, in help, you're going to get the latest revisions and help about the software. Now, something I would like to mention, the good thing with this Procon version is once you open any member, let me use maybe continuous beam. Once you open any member, it has examples that are ready. Yeah, right here. So you see it has a 2-span beam and a 4-span beam example. So if I don't know what to do, just come to my example and then uh, find out how did they put these parameters. Uh, and I should also study, and then this will help me even design quickly if I'm new to using this software. And then you see these examples have everything, including calculation sheets and all that. But don't worry, we will design each and all of these members. So that is basically introduction to the software, and we will get to learn a lot when we start um, doing analysis and design of elements in this software. So thank you very much for you have accompanied us throughout this study. You have been with us since we started, and I hope you've learned a lot. Now in our next class, since concrete is the most commonly used in construction, we are going to start with continuous beams and all the way to checking for punching shear in our next lesson. So stay in touch, kindly subscribe and press the bell icon so that once we do all these elements, you're able to learn with us, and you will become a good designer, because designers who have passed through Bromtech Engineering end up being great civil engineers and problem solvers, even when it comes to uh, supervision of works and giving out solutions. So next we are going to look at continuous beams. But before we actually come to the software, we will see how you do load decomposition from slabs to beams, and how you generally obtain the loading that you will be using here. So stay in touch. We will inform you when we do the next video. You can keep on checking our website, sorry, our YouTube channel. So thank you. May the good Lord bless and keep you, and hope you're going to become good designers in this field of civil engineering. Adios.